Our last installment of 2.3, or our limit laws. Hallelujah. We're here. All right, let's jump into it. Squeeze theorem. So we showed it in the last one. I like to call it the duh theorem, or the no shit theorem. Saying if you have a function that's less than or equal to another function that's less than or equal to another function, basically something is trapped in between. It's being squeezed. And we know that the limit of these outside suckers are equal to each other, which is equal to L, which tells us, well, no shit, the stuff that's stuck inside of it, in between it with those frickin' equal signs, so it's got to be the same thing as what's on the outside. It's this frickin' squeeze theorem. All right, let's see a problem. Because it's not going to be a problem like you saw in that last one, that long-ass proof. They're going to look a little something like this. We want to go determine what this limit is. Cool. Well, usually we just jump right in. I'm going to write it in pink, showing you I can't do this. Because I can't even write it. As a math teacher, I can't write 0 in the denominator. That's just freaking nonsense. That limit doesn't exist, so we can't just plug it in and evaluate it with our multiplication identity. Right? That limit law telling us that we can just find the limit of x to the 4th, and we can find the limit of cosine of 1 over x. The problem is, shit, that 0 doesn't go inside there. 1 over 0, that's a mistake. So that limit doesn't exist. This limit doesn't exist. Ah, shitty. But we have good news. I don't know if it's good news for you, but I like the idea. Did you know that cosine of anything, I'm going to leave this empty for just a second, is trapped between -1 and +1? Did you know that? Did you know that cosine looks like this? Trapped between -1 and 1? You never saw that before, right? Nobody's ever seen a sine wave. Like, of course, we know this between -1 and 1. It's bounded. It's trapped. It's stuck. It's squeezed between two things. So what we could actually say is cosine of 1 over x? Shit, I don't know where it ends. I don't know where 1 over 0 is actually tending towards infinity. So we're saying that this thing is like, I don't know where it ends, but shit, somewhere between -1 and 1. So that's how we're going to play the game. Okay, here it goes. Now we're going to start the game. So whatever is not, we can't find the DNE part when we have the squeeze theorem. As long as it's trapped between two things, we'll start like this. We'll say cosine of 1 over x is trapped between -1 and 1. Now our game, that's step 1. Find out what it's trapped between. We want a bounded function. When I say bounded, something above and something below. It's stuck. Okay, it's stuck. So we go to this -1, we start here, and now the game becomes we want to slowly make this look like this. So the first thing we're going to do is we're going to multiply all three sides, I guess, by x to the 4th. So let's multiply on that. So we have -1 times x to the 4th. That's -x to the 4th. Now we're going to multiply by x to the 4th. I'm going to leave that alone. Cosine of 1 over x. Sorry about that. And then we're going to multiply x to the 4th by 1. Cool. There was step 2. There's step 2. Now step 3. Why don't we hit everything with a frickin' limit? Why don't we make this thing actually, if we continue on, now make it actually look like this. So we want our next step. Now we're going to add in that limit part off on the left. So here it comes. We have the limit as x tends towards 0 of our -x to the 4th is less than or equal to the limit as x tends towards 0 of x to the 4th times cosine of 1 over x is less than or equal to the limit, oh gosh, this is a lot of writing, of x to the 4th. Okay. We're about done here because I'm pretty sure we can evaluate the limits on the outside. Think you can figure out what these limits might be when you plug in 0, so -0 to the 4th and +0 to the 4th? Think you can figure that shit out? So step 4 is just evaluate those damn limits and be like, dude, this shit's 0. So we're saying that the limit is x is trapped between, or The limit is x tends towards 0 of x to the 4th times cosine of 1 over x is trapped between 0 and 0. Oh shit, I wonder what it could possibly frickin' equal. What it equals? It equals 0. Now I don't need you to state or say by the squeeze theorem, because I think this is very, very straightforward. Like, no shit at 0. I don't think we need a theorem for it. But in math, we make sure we cover our ass everywhere. So there's your squeeze theorem. Okay, let's see another one. Now this is, you get some in your homework like this, where it's going to give you a function, and it's trapped between two things, and it's going to ask you to go find the limit of the function that's inside. Now, you're not going to be able to find the limit of a frickin' letter, but you sure as hell could find the limit of the shit that's on the outside. So let's write this down. Let's go. We'll be like, well, shoot. The limit is x tends towards 0 of the square root of 5 minus 2x squared is less than or equal to the limit is x tends towards 0 of our f of x, which is less than or equal to the limit is x tends towards 0 of this last piece, that 5 minus x squared. So there we have it, huh? We slapped a limit on both of these things because we're not going to be able to figure out what the center is. We don't solve for the center, we solve for the outsides. We knew the answer, we just frickin' state it. So we need to do the work on the others. So all we need to do is take this 0 and go plug it in, because it's in the domain of both of these functions. So you're going to end up with the square root of 5 minus absolutely nothing is less than or equal to the limit is x tends to 0 of 5 of x is equal to the limit. Oh shit, we don't have to write limit because we're going to plug in that 0, so we're going to get that square root of 5 minus nothing, but come on. I wonder what it could equal, you know? It's bigger than or equal to root 5, and it's less than or equal to root 5, then, well, no shit, it's equal to root 5. So the limit is x tends towards 0 of f of x is equal to root 5. And there's your solution. Squeeze theorem, y'all. There we be. And now let me give you a jacked up one. Let's get you jacked up. Oh, holy moly. This might actually be in your homework. I might be doing one of your homework problems right now. Actually, I'm pretty sure it's not. Holy crap. So we want to prove, we want to show, oh, I got to write this equal. It's equal to 0. Ha. So we're going to prove this. We're going to show it, actually, not really prove it. Now, this little plus sign in here is just because you're not allowed to have it come from the left-hand side and it's inside of the square root. That's the only reason that's there. That's not it's not a different problem. You're not going back to like one side of the limits. It's just because it's not in the domain of the function. All right, so here we go. What our problem is, what we have an issue on, is up here. It's not even the sign. It's the same thing. You can't plug in that 0. So that thing is trapped between 1 and -1, or -1 and 1. Sine of pi over x is trapped between -1 and 1. Okay. Cool. That's good to know. But what we can say is we're not really so concerned about that exponent. Let's add the e in. Let's do this. Watch this. Let's include this. And then let's include this. Uh-oh. I was just messing with some exponents. Now we have e to the -1st power, or 1 over e is less than or equal to e to the sine of pi x, which is less than or equal to e. Does everybody know e? 2.718, the exponential? Oh, you're going to know really well in this class. It's going to be your favorite number, besides maybe 0. So dope. I think we got this thing figured out. We found out something to where we're bounded above and below. E to the sine of pi x can never be smaller than 1 over e, and it can never be bigger than e. But it can be right there in the middle, so we bounded it. This is a rough one. Huh? We got this piece all bounded up. Now we're going to play that same game where we slowly want to introduce these two pieces to it. So on all 3 sides of the equation, we're going to put in a square root of x, a square root of x, and a square root of x times that 1 over e. Times e. All right, and remember, e is a number. It is not a variable. And now let's hit everything with our limit to make it match. And we're going to find out this. No more color coding. The limit as x tends towards 0 of a constant times the square root of x is less than or equal to the limit as x tends towards 0 of the square root of x times e to the sine of pi over x is less than or equal to the limit as x tends towards 0 of just a constant times the square root of x. Well, this is going to be 0 because you plug in 0, the square root of 0 is 0, and 0 times any number is equal to 0. And we got the other side is equal to 0. Therefore, the limit as x tends towards 0 from the positive side. Oops, I forgot to write my positive side in there. I suck. -1. I got a -1. The square root of x times e to the sine of pi over x is indeed equal to 0. So there's Squeeze Theorem. This last, the third one, that's a pain in the ass. You know, I doubt you ever see anything that tough again, but I wanted to show it to you. But problems 1 and 2, hell yeah, dude. This is what I'm all about. 1 and 2, all about that shit. Number 3, if you followed along, good job. If you get 3, if you feel like you could reproduce something like that, then you are good to go. Move on to the next. All right, I'll see you in 2.4.